Here's an intro into experiment 8, chemical properties. So what we're looking at here is whether reactions take place, specifically reactions that are going to produce a solid precipitate or a gas or neutralization, which will produce liquid water. I'll show you examples of those. So here, the majority of them are what are called metathesis reactions, where what you have is two aqueous solutions. So aqueous indicates that it's a compound dissolved in water, another aqueous compound dissolved in water. And then when you put them together, you have come up with a solid precipitate. And so we can use what are called solubility rules to predict this. And then we're also going to see observations of whether a solid did form. So what happens is you have a double replacement taking place here, where your cations and your anions switch places. So if you see barium here is barium plus 2, chlorine is Cl minus, sodium is brought down here as plus 1, and sulfate minus 2. So what you do is flip-flop the cations and the anions, and so you have two options of products. So here's one option, and then NaCl will be your other option. So you come up with the two possible products, and then you use the solubility rules to determine which one is the solid precipitate. And down here on the next page, it shows you the solubility rules. So the way these work is you look at a compound and you identify who's in the compound that shows up in one of these two rules. So the top side, these are typically soluble, and all of these bottom anions are typically insoluble. So for example, if you have NaCl, you'll notice Na is right here. It generally makes compounds soluble, and there are no exceptions. So therefore, it's going to be soluble, and that means it'll be aqueous. That's what soluble means. Whereas if you have something like AgBr, you come over here and you find Br. Br normally makes you soluble unless it has silver, mercury, or lead, which in this case it has silver. So instead of following the soluble rule, it makes it insoluble. And if something is insoluble in water, it will be a solid. So that's how you note that something is an insoluble solid, is with the little s. If it's soluble, you put it as aqueous. Down here is kind of the opposite, where if you have something like FeS, so you come find your sulfide, because iron doesn't show up in the rules, so only sulfur does. So sulfide normally makes you insoluble unless you're with ammonium, an alkali metal, calcium, strontium, barium. There's no exceptions here. So the sulfide follows its rule, it's insoluble, and it's a solid. That's how you can predict once you get to the product whether something will be soluble or insoluble. The other two things that can happen that you'll see in this lab is two different types of reactions. One where you'll make a gas. So here's two examples where you will make a gas. So you theoretically should see bubbles. But here, if you put an acid, so something like HCl, with a carbonate, okay, you'll follow your rule. You'll kind of take your cation and your anion, and you'll come up with H2CO3, because H was plus 1. And CO3 was minus 2, and you do the flip-flop rule. Then your other product would be NaCl, a plus 1 and a minus 1. Okay, the solubility rules tells me that NaCl is soluble. This guy automatically breaks down into liquid water. It's an L for liquid. And CO2 gas. This is an odorless gas, but we theoretically should see bubbles if enough were produced. And a reaction does occur here because I have made liquid water and I have made carbon dioxide gas. The other gas formation that you may see is the formation of ammonia. So for example, if you had NH4Cl and you put it with NaOH, once again, these two come together. They're both a +1 and a -1. And then NaCl again, which we know will be aqueous. But this guy is unstable and also breaks down into liquid water and ammonia gas. Once again, we could see bubbles if enough were produced, and we could smell ammonia. But here, so we want to watch out for either of these things being produced in a reaction. So the two products you're looking for are carbonic acid, H2CO3, and ammonium hydroxide, because they will both end up breaking down and forming a gas. The other reaction you may run into is an acid and base reaction, and the video will show you if this occurred. You can't see this happening unless you test the pH, but what you'll end up making is liquid water, and there will be heat produced and you'll see a pH change. So I'll do one example in the pre-lab here with you. So potassium iodide, we know that potassium is a +1 and iodine is a -1, so it'll be Ki, aqueous, plus silver nitrate. Silver is always +1, nitrate is a -1. Your reactants will always be aqueous, but you also can double check them if you'd like. And then what you're going to do, once again, is switch the cations and the anions. So your K and your NO3 will come together, and they're a +1 and a -1. You always want to watch out for the charges. And Ag +1 and I -1 will come together. Here's your two products. So what you then do is go look at your solubility rules. What your solubility rules are going to tell you is that K makes everything soluble. So the KNO3 is going to be aqueous. But the silver iodide, it'll tell you that iodine is normally soluble unless it's with silver. So where we see that, we saw that on the last picture. Where we see that is iodine, normally soluble, unless it's with silver. So that's how we know it's going to be insoluble, and that will make a solid. So yes, we have a reaction here. If you get two aqueous products, that means no reaction. So if you get aqueous and aqueous, that is a no reaction because nothing actually happened. Everybody is still floating in solution. Okay, now if a reaction occurs, if a precipitate forms, we're going to write what's called a net ionic equation. What this looks like is you are just showing the formation of that solid. So here, I'll start on the right side, identifying solid AgI. And over here, you put the individual pieces. So Ag +1 was floating in solution, and I was floating in solution, both as aqueous ions. We want to include their charges. So they were individually floating, and now they are caught up in a solid. So that's what the net ionic equation looks like. You only do that if you're producing a solid, liquid, or gas. If you're not, then you have a no reaction, and you don't have to do a net ionic equation. So here you've got two pages that look very similar. You have the predictions page. What you're going to do on the predictions page is you are going to use the solubility rules and the observations in the video to write the solid, liquid, or gas produced in any of these reactions. So NaCl will go together with sodium carbonate and you'll see if anything happens. If you get a solid, liquid, or gas, you indicate the identity. So for example, down here when you get, I'll just give you one that I know will happen, is here you will get silver chloride as a solid. So because a solid was formed, you're predicting the identity of it here. If nothing forms, then you can just write no reaction. The observations table looks the same. What you'll do is watch the video here and you'll write down what you saw. So in this one, you'll see a white solid form. So the video will tell you if you have made a solid, liquid, or gas based on the observations, and then you'll go to your predictions table and record the compound's formula, whoever you actually produced. And then you'll answer the questions in the post lab.